Hello everyone. So this is the first Japanese Mathematical Olympiad 1991. The final round, problem number 3. Let A be a positive 16-digit integer. Show that we can find some consecutive digits of A whose product is a perfect square. You may pause this video and give it a try on this problem before you watch the solution. Now let's begin. First, let us represent A as a 16-digit integer. So we let A equals to D1, D2 to D16, where Di is a digit. For I equals to 1, 2 to 16, and of course D1 is not equals to 0. Now the problem asks us to show that we can find some consecutive digits of A whose product is a perfect square. What does it mean? So it means that we want to show there exists I and J. We suppose I is lesser than J such that Di times Di plus 1 times so on until Dj is a square of some natural number. So this is our goal. So first, maybe we can look at the product of the first few digits of A. So we let S1 equals to D1, S2 equals to D1 times D2 until S16 will be equals to D1 times D2 times so on until D16. So if one of these is a perfect square, then we are done. Else, which means that we assume that none of S1, S2 to S16 is a perfect square. Now we look at, since Sm will be equal to 2 to power of Am, 3 to power of Bm, 5 to power of Cm, 7 to the power of Em, because we had used D for m equals to 1, 2 to 16. Because Di is between 0 and 9 for I equals to 1, 2 to 16. Why is this true? Okay, because Di is between 0 and 9 and Di is a digit. So the prime factor of Di, the possible prime factor of Di is only 2, 3, 5, and 7, which is the prime number in between 0 and 9. So we have its Sm will be represented as 2 to the power of Am, 3 to the power of Bm, 5 to Cm, and 7 to Em. Now we have 16 possibilities of Am, Bm, Cm, Em mod 2, modulo 2. Okay, so each one of these could be 0 or 1, 0 or 1, 0 or 1, 0 or 1. Okay, now if we have everything is 0, then we get that the Sm is a perfect square. Now since none of S1, S2 to S16 is a perfect square? We must have, by pigeonhole principle, I and j, let's suppose I lesser than j, there exists I and j, I lesser than j, such that let's say this is AI, BI, CI, EI is congruent to AJ, BJ, CJ, and EJ modulo 2. Hence, hence we have that Sj over Si is equals to, let's say, this is equals to 2 to the power of Aj minus Ai times 3 to the power of Bj minus Bi times 5 to the power of Cj minus Ci times 7 to the power of Ej minus Ei, which also equals to is di plus 1 times di plus 2 times so on until dj is a perfect square. Since Aj minus Ai, Bj minus Bi, Cj minus Ci, Ej minus Ei is congruent to 0, 0, 0, 0 modulo 2. Then we are done. So so this is the proof that we had shown that we can find some consecutive digits of A whose product is a perfect square. Thanks for watching. If you find this video helpful, please like and subscribe and share this video with your fellow Math Olympian or just your fellow mathematics enthusiast who wants to study and learn mathematics. Thanks for watching. See you next time.